Stays to here, and I think a lot of people are finding it hard to be here. But anyway, my name is Vivek, and in today's session, we are going to look into how exactly we can provision or dynamically provision a Kubernetes volume with some pre-existing data in it. Before we actually move ahead with that, I would like to very briefly introduce myself. My name is Vivek. I am a member at technical staff at Veeam. I have a small YouTube channel where I talk about Kubernetes, containers, and Go. I maintain some small open source projects as well as Canister, that is a CNCF sandbox project. Apart from that, yeah, you can find me on internet using my handle, Vivek Singh GZITS. And now, let's just talk about what exactly are Kubernetes volume populators. So whenever we try to provision volume on Kubernetes, most of the times, if not all, most of the times the volume is going to be empty. So you created a PVC resource. PVC resource eventually resulted into creating a volume in the backend system. And most of the time that volume at the backend is going to be empty. I'm emphasizing on most of the times because in some cases, you can actually create, even without volume populators, you can create Kubernetes volumes with some data in it, right? And the source of that data can either be another PVC, so that use case would be cloning a persistent volume. So, and the other use case is restoring a volume snapshot. So you can create a PVC with some data even without volume populators, but you are just limited to certain number of sources for your PVC. So you can just have two sources. One source is another PVC, and that would result into cloning that PVC. So the new PVC is going to be clone of the other PVC. And the other case is having volume snapshot as the source of your PVC. And in this particular case, your resultant PVC is going to be restoring the volume snapshot. When I say volume snapshot, I mean the snapshot that we created using volume snapshot API. So this is what the current stage of creating volume looks like without volume populators. But the main problem here is we are limited to the sources. We can just use either another PVC or a volume snapshot resource. But let's say my use case is that I want to use any source to my PVC. I should be able to populate data into my PVC using any source. Let's say, and that's what we are going to look into today. So volume populators eventually are just, let's say, some custom resource definitions and a controller behind it. And eventually all these pieces together are going to work to make sure that the new PVC that you are going to create is going to get populated with some pre-existing data. So yeah. Let's talk about some of the use cases where you would want to use volume populators. So let's say you are a company, you are a project that enables people to run virtual machines on Kubernetes. So you have a project, you are a company that helps customers to run VMs on Kubernetes. To run VM, we know that we would need a disk image. So if we did not have volume populators, what we would do is we would ask users to import the disk image into a PVC and then mount that PVC into the VM. Let's say we have a VM resource. So we are talking about the scenario where we don't have volume populators. We asked users to manually import the disk image into the PVC. We mounted that PVC into the VM, right? But that is a problematic process, I would say. The responsibility to import the disk image lies on the shoulders of the users, right? And that can actually be resolved by using volume populators. So what we can do is, as you can see here on the right-hand side, I have a resource called VM disk image populator, and that resource specifies a disk image URL. And in the source of the PVC, we have used this resource. So what this results into is eventually we are going to get a PVC. That PVC would have the disk image that is there at the specified URI. We are going to look into this in a much more detail in just a second, so things are going to make much more sense. But this is one of the use cases. Also, don't hesitate to just ask questions. You don't have to wait for the end. We can talk about the questions whenever you have them. The other use case that I would like to talk about is, let's say you are a data management company. Your company, your project helps manage data of the stateful applications on Kubernetes. So when I say data management, I mean snapshot the application, restore it into another namespace, another cluster. So you snapshotted a PVC from a particular namespace. You want to restore that PVC into another namespace. So what you can do is, like we see here, when you try to restore the PVC, while restoring, you can specify that the source of the resultant source of the restored PVC is going to be a restore point, let's say. And this restore point can be anywhere. This restore point can point to a particular object in the object store and things like that. So if you see here again, we have another volume populator called restore point restorer. When I say volume populator, I eventually mean a set of resources and a custom controller. So here, what would happen is, as soon as MySQL PVC gets to ready state, gets to bound state, it would have the data it would have the latest data for the MySQL application. This is one of the examples. The other example that I would like to quickly talk about is, let's say, I call it generic HTTP populator, and this is the one that we are actually going to deep dive into. We are going to look into the code base, how do we install it, and things like that. So generic HTTP populator is, let's say, a populator that is going to populate a PVC with the data that is present at an endpoint. So if we look into, again, the custom resource here, we have a URI. URI can be used to configure a remote endpoint. And in the left-hand side, we are referring to that volume populator in the PVC resource that I created. Again, as a result of this, when this PVC myClaim gets into bound state, it would have the data that is there in this endpoint that we have configured. So now let's quickly talk about the custom resources and custom resource definitions that are involved in this particular scenario that we just talked about. So volume populators are just a Kubernetes resources that can be used to register a new volume populator on your Kubernetes cluster. So generic HTTP populator, as you see here, is a kind of volume populator. So first of all, we would need to create a CRD that is going to introduce this particular resource. Obviously, generic HTTP populator is not something that Kubernetes cluster knows already. So we are going to create a CRD that is going to introduce this particular resource. Sorry about this. So we are going to create a CRD that is going to introduce this particular resource. And once we have created that CRD, we are going to create a resource of type volume populator to make sure that I register this particular resource as a volume populator in the cluster. Now, to register this particular resource, when I say this particular resource, I mean generic HTTP populator. To register generic HTTP populator as a volume populator in the cluster, we need to create an instance of volume populator resource. Now, again, to create a volume populator resource, we need to make sure that volume populator resources are available on the cluster. There is a CRD that registered volume populators in the cluster. If volume populators resources are not available, we will have to create the CRD that introduces the volume populator resources. And then, like I said, we can create an instance of volume populator resource that registers this particular generic HTTP populator as a volume populator. I hope that makes sense now. But again, you can ask questions whenever you have them. Once we have created all those things, we are going to create an instance of generic HTTP populator like we are doing this here, and that instance is going to be referred from the PVC. So yeah, this is, let's say, one of the most important slides in the presentation. If you have any question about this, please feel free to ask. So you can see here in the application namespace where we are trying to create the PVC, we have volume populator CR instance, and that volume populator CR instance is referred into a PVC. So as soon as we create this particular PVC, obviously, if the storage backend is CSI supported, external provisioner is also going to get informed about creation of PVC. And that external provisioner would look into the PVC request, and it would not actually be able to do anything because it would not know the data source that is set into the PVC resource. And if external provisioner, or let's say CSI in a way, did not know what to do about the PVC, it's just going to kind of ignore the request, let's say, and the PVC would just be stuck into the pending state. And once the PVC is stuck into pending state, we are going to write, as part of, let's say, writing volume populator, we are going to write a custom controller. That custom controller is, if you see here in the populator controller namespace at the step 4, let's say, that controller is also listening on the, let's say, create, update, or delete events of PVC. And this populator controller, as soon as it knows that there is a request created for a particular PVC resource with the data source set to the same volume populator resource that this controller is responsible for. There are chances that in a particular Kubernetes cluster, there are multiple volume populators, and they are responsible for handling sources for different type of resources. So this populator controller would make sure that it's actually responsible for generic HTTP populator type of volume populator. And as soon as it verifies that, it is going to create a temporary pod. Let's call it a populator pod, and it's also going to create a temporary populator PVC. And obviously, this populator PVC and a populator pod are going to be attached to each other. And this is where the most important part comes in. This new populator pod that gets created is actually going to have the data that is going to download or populate the data into the PVC, right? So, for example, in case of generic HTTP populator, we are planning to populate the data from the data that is present an HTTP endpoint. So, populator pod is going to make an HTTP request to that endpoint and going to download the data and going to write it to the PVC. And obviously, when the data is written to a PVC, it in a way means that now the data is actually persisted into a backend volume, into a PV, right? And the code that runs on populator pod is the code that we have to write. We don't have to be worried about anything at all in this entire architecture, I would say. And I think that is the most important part here. Once the data has been written by pod into the PVC, or once the data has been populated by the populator pod into the PVC, what populator controller does is it updates the reference in the persistent volume. If you look into that persistent volume initially refers to the PVC that was temporarily created. But once the population was completed, the PV is updated to refer to the application PVC, the PVC that is created in the application namespace. So now we have a PV where the data was written, and that PV is pointing to the application PVC that we created. So now we were actually able to achieve what our goal was, that this PVC has the data that was there in the HTTP endpoint. Before I move forward, the other thing that I would like to highlight is, I think I talked about it earlier, everything apart from what runs in the populator pod is done by a library that is maintained by upstream folks, let's say. Only thing that we have to do is write the code for the pod that runs in the temporary populator pod. Everything other than that, for example, creating the populator pod, creating the temporary populator PVC, changing the reference in the PV to point to the original PVC. All of these things are actually done by the populator controller, which we are not going to write. We are just going to utilize an upstream utility that is going to do all these things. Yeah. Now, let's go ahead and try to very briefly talk about the data source and data source ref fields that we saw for the PVC API. So, even before volume populators came into picture, PVC API actually supported a field called data source, and that data source field supported two kinds of resources, either another PVC or a volume snapshot resource. But like I said, the problem was that we want to, or our use case was that we want to be able to configure any resource as a source for a PVC. So initially it was considered that data source field itself should be extended in such a way that we should be able to configure any resource, but that resulted into some backward compatibility issues, and because of that, a new field was introduced for PVC API called data source ref. So this is the let's say originating story between data source and data source ref fields of the PVC API. Now, we know that we can only configure two types of resources for data source. For data source ref, we can actually specify any kind. For example, we cannot configure any resource from the core API group, excepting persistent volume claim here. The other distinction between these data source and data source ref fields are they must always be same. Kubernetes API server basically makes sure that data source and data source ref fields are pointing to the same resource all the time, and the reason is, using these fields, we are basically configuring source of the PVC. And if we are trying to configure two sources of a PVC, which source should be used as the final source of the PVC? And that is the reason it's important. Even if we make some mistake, API server is going to make sure that these two fields are set to the same resource. And obviously, these fields are not mutable. They are immutable basically. Yeah, I think now let's go ahead and try to look into the installation and demo of the volume populator that we just talked about. So I'm going to pull up my terminal here very quickly. So, like I said initially, is the font family okay?
You can probably zoom in a bit more.
Yeah.
There we go.
All right. So, like I said initially, so now we know that volume populators construct are basically combination of custom resources and a controller. So let's just go ahead and check if we have volume populators available in the cluster. So as we can see here, our Kubernetes cluster, it's a DigitalOcean 3-node cluster that I have set up for this demo. And as we can see here, volume populators are not available as a resource in this Kubernetes cluster. So first of all, what we are going to do is we are going to create a custom resource definition, and that custom resource definition is going to introduce this particular resource in the cluster. And let's quickly go ahead and try to look into that custom resource definition. So if you see here, that this is the CRD. I have not created it. This is upstream CRD that is available to basically introduce volume populator resources in the cluster. And this is going to introduce this particular resource in the cluster, and I'm just going to create the resource now. So create -f. And after this CRD is created, at least now we should be able to see the volume populator resources. So get volume populators, and now at least we don't see that error that volume populators are not even registered. So now what we have to do is we have to create the CRD for our generic HTTP populator resource. So let's go ahead and try to do that as well. And we can go ahead and quickly look into this CRD as well. If you see here, as part of this CRD, we are only introducing a resource that is going to have, that should allow us to specify a URI while creating the resource. So we have created the CRD, we have registered, we have made sure that volume populator resources are available. Now let's go ahead and create the volume populator resource to register this new CRD as a volume populator. So create -f, and we are going to create the volume populator resource, and we are going to look into this resource as well. And as you see here, we are creating a resource of type volume populator. It's called GHP, and it's basically making sure that now this particular group and kind is registered as a valid volume populator in the cluster. And once we have created this volume populator, let's just go ahead and try to create an instance of generic HTTP volume populator. And that instance is going to be, let's say, this particular resource. If you see here, we are just specifying a URI, and this URI has the details about where exactly do we want to download the data from. So let's go ahead and try to create this access readme. But before doing that, let's go ahead and try to install the populator controller. So I'm going to install everything in populator namespace. Sorry, controller namespace. That is not available right now. So it's going to deploy the populator controller in the controller namespace, and we should be able to see all those things coming up right now. Now, let's just go ahead. I'm also going to okay, and now we are going to create this PVC. If we look into this PVC, this PVC is just referring to the generic HTTP populator that we created. And as soon as this PVC is created, if you see here, in the application namespace, the PVC is in pending, but in the controller namespace, a new populator pod got created, and that populator pod is actually going to write the data into the PVC. And that PVC is eventually going to get bound to the application PVC. Now, let's just go ahead and quickly check that the PVC that was created in the application namespace has the correct data. So to do that, I'm going to create a simple Nginx pod in the default namespace. That's going to get created in just a second. But while that is getting created, let's go ahead and look into the code very quickly. So we have two main components, the populator controller and the actual populator pod. So the populator controller is this piece. If you see here, populator machinery.run controller, this is the piece that I was talking about. That is actually responsible to do everything, creating the temporary pod, creating the temporary PVC, mounting those two things, and once the data is populated, deleting the temporary PVC and deleting the temporary pod, and basically referring the original PVC from the PV. All these things are done by this particular run controller call. This creates a controller and then does all those things. The populator pod runs this particular pod. Whatever we see in the populate here, that is done by the populator pod. So if you see here, all we are doing is we are just making an HTTP request to that URI that was configured in the custom resource, and then we are writing the data into the mounted PVC. So the temporary PVC was mounted into the temporary pod, right? That is the reason we are able to write the data into that PVC. Now, let's just go ahead and try to exec into that Nginx pod to check the data was written. And if you see here, we should be able to see a file called readme.md, and that readme.md has the data that is there in the HTTP endpoint that was configured. Now let's get back to our presentation. Some small limitations that we have here. The application PVC that we want to dynamically provision with some data cannot be in the same namespace where controller is installed because of obvious reasons. If application PVC is created in the controller namespace, controller would create a temporary PVC for that application PVC, and for that temporary PVC, the controller would create another temporary PVC, and we would get into this infinite loop. That is the reason we cannot basically create the application PVC in the controller namespace. The other problem is the populator pod that we saw. Let's say you have some instances with that populator pod where you are running things offline in a isolated environment. You need to configure image pull secret, and I don't think there is a way right now to configure, let's say, image pull secrets or anything like that for the populator pod, temporary populator pod. Yeah, I think that's pretty much it. If you have any questions.
Thank you, Vivek.
Yeah.
Is that working? We have 3 minutes for, I don't have a watch. We have 3 minutes for questions. Anyone? Okay.
Yeah, really nice talk. I think my main question revolves around like sort of the intent of populating from a dynamic source, where I feel like a lot of applications you really want to have like a static volume that you're pulling in or something like that. It seems like it could be really hard to debug if you're pulling in data from a generic HTTP endpoint and you're not sure what that data looks like. So I guess my question is like, what's the advantage of doing this versus just having some out-of-band process that copies the HTTP data onto a volume snapshot that you then load into your volume at runtime?
Mm-hmm. Yeah, that makes sense. That's a good question. So here is the thing. I'm not really sure if you are aware of KubeVirt. KubeVirt is a project that basically helps us run virtual machines on Kubernetes. So let's say I'm a user. I want to use KubeVirt to run Ubuntu, right? You are a user that want to use KubeVirt to run Red Hat, right? So in this particular case, the disk image is kind of dynamic, right? We can basically use, we should be able to use any disk image that I want to, right? And this is where I think the solution comes into the picture. Yeah, and the same goes with the data management software that I talked about, right? you have written a product that basically helps me manage my database on Kubernetes. I should be able to restore the PVC using any restore point that I have exported in the object store. Yeah, I hope, yeah, thanks.
We have time for one more question.
I was just wondering what mechanisms exist to communicate back any issues with population, any error states or delays or things like that.
Yeah. So I think when we write the populator pod, right, the temporary populator pod that was created by controller pod, that can actually generate events for the PVC, the application PVC, right? So if I go ahead, we are out of time, I think. But if I talk about the temporary populator pod, right, that populator pod knows about the application PVC, right? So if it has the proper authorization, it can generate events for the application PVC that the data has been populated, I got into this problem, and then things like that. Yeah.
All right, let's applaud Vivek.
Oh, thank you.
Thank you very much. We have our next session in 5 minutes.
And I'm pretty active on Twitter, I think. So if you ever get into any questions, any situations, please feel free to just ping me. I would be more than happy to help you. All right, thanks, folks.